Hello, this is Mr. Stansbury. I'm going to take you through the 18E assignment. All right, so we start here with number one. The heights of 200 lilies are normally distributed with a mean of 40 centimeters and a standard deviation of 3 centimeters. Sketch a normal distribution diagram to illustrate this information. Okay, so they're just asking us to draw ourselves a little normal curve here, right? Just our little bell-shaped curve. And that means right down the middle here is going to be our mean, which they tell us is 40, right? And then one standard deviation up from that will be, it's a standard deviation of 3, so this will be 43. And then another one would be 46. And then one more would be 49, right? So this is the mean. This is the mean plus a standard deviation. It's the mean plus 2 standard deviations and the mean plus 3 standard deviation. And that's like our little mu. That's our our mean. And then this is our mu plus 1 standard deviation plus 2 standard deviations plus 3 standard deviations, right? And then also we can go backwards here. This is 37. That's minus a standard deviation. And there's a second one. Minus 3 more is 34. That's minus 2 standard deviations. And then out here, this would be 31, and that's minus 3 standard deviations from the mean. Okay? Let's see. Indicate clearly the mean and the heights within 1, 2, and 3 standard deviations of the mean. All right, so that looks pretty good there. Find the probability that a lily has a height less than 37 centimeters. So really probably the easiest way to do all of these is just use our graphing calculator and use our normal CDF. Okay, so I'm going to pull up our graphing calculator here. And this entire section, this 18E, is this is all the normal distribution. So what we're going to do is we're going to go under the distribution piece of the graphing calculator. So I'm going to do second variables, which is the distribution, and that'll give us distra for distributions. And we want the normal CDF. Okay, so we're going to push enter, and then normal CDF here. On some calculators, you have to enter in all of your data. In some of the other calculators, I'll show you a different version here in a second. It'll kind of walk you through what to put for each piece. Okay, so let's pull up what we need to put out here. Okay, so here we go. We've got on this here, we've got to put the normal CDF, which we have, and then we have to put the lower bound, comma upper bound, comma mean, comma standard deviation. So the lower bound is the lowest we want this to have. So we are doing part B here. Find the probability that a lily has height less than 37 centimeters. Okay, so the lowest we want this to be would be, if it's just less than, we could go anywhere from 0 up to 37. So I'm going to put 0 in there and then hit the comma. And then now I'm going to do the upper bound. The highest we want it to be is 37. So comma 37. You don't have to put spaces in there. Comma the mean, which they give us up here, is the mean is 40. Okay, comma, and then our standard deviation says right there, standard deviation, which is 3. And then we close our parentheses and push enter, and it will tell us right here, that's our percent as a decimal. So you can say 15.9% or 16%. Or 0.159 is fine also, whichever one you want to do. So I'm going to go with 15.9% is the probability that a lily has height less than 37. Okay. Now, your calculator might actually walk you through everything. This one, I believe, will do that for us. We go into, it's the same spot, second variables, which is the distribution. We go into normal CDF. And then this one here will actually walk you through each piece. So they're going to ask you, what's the lower bound? Okay, so the lower bound is 0. The upper bound we want is 37. The mu, the standard deviation there is 40. Sorry, the mean is 40, and then our standard deviation is 3. Enter, and then it's going to, you push paste, and it's going to paste it all into the formula that we just did on the other calculator. Push enter, and we again get 15.9%. Okay, so either one of those calculators will work. Okay, let's go into C here. Find the probability that a lily has height between 37 and 46. So, second variables, which is the distribution, we're going to go normal CDF. And then now our, again, lower bound, upper bound, mean, and standard deviation. So the lower bound is going to be now 37, comma, and then the upper bound is 46. And then our mean is still 40. And our standard deviation is still 3. Close our parentheses, hit enter, and we get 81.85. So I'm going to call that 81.9%. That's the probability. Okay. D, find the expected number of lilies with a height greater than 43. So the first thing we're going to want to do is find the probability that's going to be has a height greater than 43. So back to our graphing calculator, second distribution, normal CDF, our, let's see, lower bound, it's greater than 43, so 43 is the lowest. And then upper bound, we don't have an upper bound, we want it to be 43 or bigger, so I'm just going to put in, say, 200. Okay, that's pretty big, that'll work. And then I'm going to put in my mean and my standard deviation, which again is 40 and 3. Okay. So that gives us that it's a 15.9% probability that it's going to have a height greater than 43. Okay, so let's go with, I'm going to write this as a decimal, and I'll show you why here. 0.159. Okay, now we have 200 lilies, so if you're finding the expected number of lilies, about 16% of those 200 lilies are going to have a height greater than 43. So I'm going to take my 0.159, I'm going to multiply it by the total lilies I have. Right, so take that number times 200, and that means we're going to have about 32 lilies. Oops, I spelled that wrong, sorry. L-I-L-I-E-S. Okay, so about 32, we should expect about 32 lilies to have a height greater than 43 centimeters. Okay, all right. Moving on to number 2. Set of 200 IQ scores is normally distributed with a mean of 100, standard deviation of 10. Calculate the probability that is represented by each of the following diagrams. So it's really pretty much what we just did on the first one, except for now they're giving us pictures instead of the actual numbers here. So this one here, we're going to calculate. So we're going to do second distribution, normal CDF. Let's see. Oh, I should put in our info, what we need to go where. It's the lower bound, upper bound, standard deviation, and mean. But let's put that on there just so we don't forget. Okay, kind of stuck it right in the middle of the problem there, but this should work. So, normal CDF, lower bound. The lowest we want this to be, I'm just gonna, they show 50. I'm just gonna put 0 in there. That's not gonna hurt. So we want this to be anywhere from 0 up to 90. And the reason why I picked 0 instead of 50 is there's going to be a really small number in there that could possibly be 50. If I put all the way down to 0, then I know I'll include everything all the way down. It probably isn't going to make much, if any, difference, but just in case. Okay. The mean, it tells us, is 100, and the standard deviation is 10. Close our parentheses, and that tells us it's going to be 15.9% for this one here. So this is 15.9%. Okay, this one here is from 120 up. Okay, so let's second distribution, normal, CDF, we want to go, our lower bound is 120. Our upper bound, again, I'm going to put like 250. Just something big. The mean is 100, and our standard deviation is 10. Okay, push enter, and I get 0.227. So I'm going to call that 2.3%. Okay, so that's how much area. That's 2.3% of all this area under the curve. Just that little piece, 2.3%. Okay, let's look at this one here. So that one here, second distribution, normal CDF. We want to go from 80 to 110. So 80 is the lower bound, 110 is the upper bound, 100 is the mean, and 10 is the standard deviation. Push enter and we get 81.85, so we'll call that 81.9% of the data is in this blue shaded piece here. Okay, let's see. B, find the expected number of people with an IQ of more than 115. Okay, so more than 115. Second distribution, normal CDF. Our lower bound, 115, is the lowest we want this to be. And we can go up as something, we can have as high as we possibly can get. So I'll put 250. And then our mean is 100. And our standard deviation is 10. Okay, and that gives us 6.7%. Oh, sorry. Let's do this. 0.668. 0.668 says, since we're looking at the expected number, we got to take that and multiply by the total number of people. And that was there's 2,000 IQ scores. So we take that 0.668 times 2,000, or in this case here, I've already got my answer in there. I just push times 2,000. And we're going to expect about 134. About 134 people should have an IQ of more than 115 of the 2,000, right? Because isn't that what we started with? Yeah. 2,000 IQ scores. All right. Let's move on to number 3. The weight of kumquats is normally distributed with a mean of 20 grams and standard deviation of 0.8 grams. It's known that 15% of the kumquats weigh more than k grams. Find the value of k. Okay, so this is on our handy-dandy graphing calculator here. We are still doing a distribution, but pretty much whenever they give us percents here, what we want to do is we're going to use the inverse norm instead of the normal CDF. So these are really the only two that we're going to have to use. Okay, so inverse normal is simply, instead of an upper and lower bound, you just want to do the percent. Now the percent can be a little tricky. Okay, so it says it's known that 15% of the kumquats weigh more than k grams. So you can kind of look at it like this. So here's our little normal distribution. 15% of the kumquats weigh more than k grams. So we are looking for this right here, the top 15%. Okay, so really what we want to know is this over here is, say, 0%, and this over here at the end is 100%. We want to know what percent this is. So since it's the top 15, we would actually go 100% minus 15. That means we are actually looking for the 85th percent. So 85th percent and up. Okay, so what we want to do on here, instead of putting 15%, and you put that in as a decimal, we want to know 85% and above. So what we're going to do is put 0.85, and then we've got our mean of 20, so 0.85 comma 20, and then comma the standard deviation, which is 0.8. Close our parentheses, and we get 20.8. Okay, let's see. Find the value of k. Okay, so known that 50% of the kumquats weigh more than k grams. So that means that 15% of the kumquats weigh 20.8 grams. Right? That's the so if you find all your kumquats, all the ones that are 20.8 and above should be about 15% of your kumquats. All right? All right. Moving on. Number 4, the weight of cans of sweet corn is normally distributed with a mean of 220 grams, standard deviation of 4 grams. It's known that 30% of the cans weigh more than W grams. Find the value of W. Okay, so again, we got our percents here, so we want to figure out what percent are we looking for. Okay, so it's known that 30% of the cans weigh more than W grams. So we're looking again for the top. We're looking for the top 30%. Okay, so to figure out, again, this over here is 0. This over here is 100. So if it's the top 30, we got to take 100 minus 30. Gives us, we're looking at 70% here. That's the magic mark that we're looking for here. So on our calculator, second variables, which is distribution, we're going to, since we're talking about percents here, we're going to do the inverse normal. And we are going to do 70%, so that's 0.7. And then our mean, which is 220. And then our standard deviation, which is 4. Close that out, push enter, and we get 222.1. So we're going to call that that W is 220 grams. About 220 grams. Okay. Okay, last one here. The weights of cats are normally distributed with a mean of 4.23 kilograms, standard deviation of 0.76 kilograms. Write down the weights of cats that are within one standard deviation of the mean. Okay, so let's see, if we're just writing down the weights of the cats, we're going to start with 4.23, and then if we're going to go down one standard deviation, we subtract 0.76, and then we're going to start with 4.23 to go up one. We're going to add 0.76. Okay, so let's calculate those so I don't mess them up. So we got 4.23 minus 0.76 gives us 3.47. And then this one here is going to be 4.99, right? Okay. A vet weighs 180 cats. Find the number of these cats that would expected to be within one standard deviation of the mean. So basically between those two values. So quick way here is second variables, which is our distribution. We are looking between two numbers, not a percent. So we're going to go to the normal CDF. Okay, it's going to be the lower bound, which is 3.47 is the lowest that we want, comma, 4.99 is the highest that we want. Let's see, mean is 4.23. And our standard deviation is 0.76. Close that off, push enter, and we get 68 point, we'll call that 68.3. So that's 0.683, is that right? Yeah. Okay, but we're finding the number. So whenever it's find the number, we got to multiply that 0.683 times 180 to find the total number of cats. Right? So just take that, multiply by 180, and we get 122.8. So we're going to call that about 123 cats. See, calculate the probability that a cat weighs less than 3.1 kilograms. So again, back on our graphing calculator, we are looking at, nope, not looking at percents. So second distribution, we are going to do normal CDF. So we want to be less than 3.1. So we want to go anywhere from 0 up to 3.1 with our standard let's see, sorry, our mean of 4.23. 4.23, and our standard deviation of 0.76. Right? Yes. Okay, so that gives us 6.9%, about 6.9%. Okay. Oh, oops, I wrote that in the wrong spot. That would be here. About 6.9%. D, calculate the percent of cats that weigh between 3 and 5.35 kilograms. Okay, so we get our calculator back out. Second distribution, normal CDF. 3 is our low, and 5.35 is our high. Mean is 4.23. And our standard deviation is 0.76. Close that off, and that is calculate the percentage of cats. That's 87.69, so we're going to go with 87.7%. Okay, and then the last one, it's known that 5% of the cats weigh more than W kilograms. Find the value of W. So now we're back to the percents, so now that's the inverse normal, right? Here's 0. Here's 100. We are looking for the top 5% because it's known that 5% of the cats weigh more than W kilograms. So we are looking for this top 5. So we got to take 100 minus 5 to give us 95 percent is really what we're looking for. That's this number that we're going to enter into our calculator. So second distribution, we're talking about percent, so we're going to do inverse normal. We want to find the top 95%, so 0.95. And then our mean, which is 4.23. And our standard deviation, which is 0.76. Okay, push enter. And let's see, find the value. 5% of the cats weigh more than W kilograms, so that is 5.48 kilograms is the top 5%. So I got to be 5.48 kilograms or more. Okay. All right, that is it for the 18E assignment. If you have any questions, please feel free to ask in class. Thanks.